This video is on solving systems by the addition or elimination method. The first step is to make sure the equations are lined up. So as we can see, we have the x term over the x term, the y term over the y term, the equals over the equal, and then the constant over the constant. For step 1 here, we're going to skip. We have nothing to line up. It already is given to us lined up. Step 2 is make opposites. So if we look here, we don't even need to do step 2 because 3 and negative 3 are opposites. So our x terms are already opposites. So now, step 2, we can skip. We have opposites right here. So after step 2, we're going to add the equations together. So 3x plus negative 3x, those cancel and make 0, x. Then we have negative 4y plus 2y, that equals negative 2y. 11 minus 7 is 4. Then divide, and then after we add, now we solve this. So we're going to divide by negative 2, and we get y equals negative 2. Okay, then our very last step is we're going to substitute this value back into the original problem, one of these problems, to get the x value. So this was step 3, where we added. Step 4 is where we solved. So the very last step, step 5, I'm going to go back to the original problem, and I'm going to pick the top one. You could pick the bottom equation. And now that we know what y is, we're going to replace the y with negative 2. So we have 3x minus 4 times negative 2 equals 11. So negative 4 times negative 2 is positive 8. Then I'm going to subtract 8. Divide by 3. And we get our x value is 1. So our solution is 1, negative 2. So x is 1, y is negative 2. So the nice thing about systems is you can check whether this is the correct answer and know for sure that this is correct. So to check if 1, negative 2 is the correct solution, we're going to go back to the original problem, and instead of an x, I'm going to replace x with 1. We'll replace y with negative 2 and see if that gets you 11. So we have 3 plus 8, and that is 11. But that's not enough to know if it's right. We have to do a second check. We have to take the other equation, negative 3x plus 2y equals negative 7, and we're going to plug in our answer. And if it works here, then we're confident 100% we are correct. This is x, this is y. So negative 3 times 1 is negative 3, positive 2 times negative 2 is negative 4, and these combine to make negative 7. So it works. So this is the correct solution. Okay, let's take a look at this example here. So the first step is to make sure everything is lined up. So we have the x term over the x term, the y term over the y term, the equals, and the constant. So step 1, skip. Already done for it. Step 2 is to make opposites. So 3 is not the opposite of 2. Negative 1 is not the opposite of positive 5. So let's add, we need to make x or y opposites, not the constants. So we have to do step 2. So we need to make either the x's opposites, so I could multiply this by negative 2, because then it would make it negative 6, and then I'd have to multiply this by 3, and then I'd have positive 6. Okay, but I prefer to multiply the top instead by 5, because then I'm going to have 5 times negative 1, and that will make it 5, and then I'll have 5 here, or negative 5 here, and positive 5 here. So this is less work. I don't have to multiply both the equations by a number, only just the top number, or top equation. So 5 times 3x is 15x. This is step 2. 5 times negative 1 is negative 5. Y. 5 times 11 is 55. This one, I didn't have to multiply anything by, or this equation by anything, because I wanted the 5 there. So step 2 is now completed. I have negative 5 and positive 5. They are opposites. Okay, now we're going to add. 15x plus 2x is 17x. Negative 5y plus 5y, that's 0. That was the purpose of doing this here. And 55 plus 13 is 68. Then we're going to divide both sides by 17. So we are doing step 4 now. We are solving. And we get x equals 18 divided by 7 is 4. Okay, now step 5, we are going to substitute. We're going to go back to the original problem, pick one of these equations. So I'm going to pick 3x minus y equals 11. I could have picked this one, that would be fine. And instead of 4, or instead of x, I'm going to put a 4 there. So 3 times 4 minus y equals 11. So 3 times 4 is 12. And then subtract 12. We don't want to know what negative y equals. We want to know what y equals. So I'm going to divide by negative 1. And we get y equals 1. So our solution is 4 for x, 1 for y. And again, you could plug these values in and make sure it is correct. Okay, let's take a look at this next example. Let's get our steps out here. So the first step is to make sure everything's lined up. So the y term is lined up with the y term, but then I have an equal, and I don't have an equal here. So these equations are not lined up. So step 1 is I need to make them line up. So I'm going to pick one of the equations to stay put. So I choose the first equation to stay put. I'm going to leave the negative 7y and the 2x on the same side and the constant left alone here. So on this equation here, I'm going to rearrange it by adding 3x to get rid of it on the right side, because I want the constant left alone like it is there, and then I'm going to add 3x here. So now I have 5y lined up with the negative 7y, and then I have a 3x lined up with the 2x, and the 17 lined up with the constant. So this was step 1, get them lined up. Okay, then step 2 is we're going to make x or y terms opposite. So if we look here, negative 7 and positive 5 are not opposites. 2 and 3 are not opposites. 1 and 17 don't count, just the y and the x terms. So I can multiply the top equation by 5, and the bottom equation by 7, because then I'd have negative 35 and positive 35. Or I can multiply the top equation by negative 3 and the bottom equation by 2, and then I'd have negative 6 and positive 6. Doesn't matter, I'm going to go with this option. So step 2 is I'm going to make opposites. So negative 3 times negative 7y is 21y, and negative 3 times positive 2 is negative 6x. Negative 3 times 1 is negative 3. Now I'm going to do that same thing here. 2 times 5y is 10y, 2 times 3 is 6x, and 2 times 17 is 34. So that was step 2. I have opposites now, right here. Okay, now step 3, I'm going to add these. So 21y plus 10y is 31y. This made 0. And then we have negative 3 and positive 34. That makes 31. Step 3 was add. Step 4 here is to solve this. So we're going to divide both sides by 31. And we get y equals 1. Okay, then the very last step, step 5, is we need to substitute to get the second value. So we're going to go back, not here, because what if we made a mistake over here? We're going to go back to the original problem that was given, select one of them. So I'm going to go with, it doesn't matter, I'm going to go with the bottom equation. So 5y equals negative 3x plus 17. And instead of y, I'm going to put 1 there. So I have 5 times 1 equals negative 3x plus 17. 5 times 1 is 5. I'm going to subtract 17. Negative 12 equals negative 3x. And lastly, divide by negative 3. And we get 4 for x. So our solution is 4, 1. Okay, this next problem I'm not going to solve out completely. I just want to discuss how they are lined up. That was step 1, just to make sure they're lined up. But I want to focus on making x or y term opposites. So looking at this, we don't have opposites. 4 is not the opposite of 6. 6 is not the opposite of 9. So what I could do is I can multiply the top equation by 6, because then 6 times 4 is 24, and then I can multiply this by 4, and I'd have 24, but one of them has to be negative. So let's say I make that one negative. Then I'd have 24 and negative 24x. Or I can multiply this by 3, because then I'd have 12, and then I can multiply this by 2, and then I'd have 12 and make one of them negative. That would work. Or, there's lots of options here. If I want to get the y's to go away, I can multiply the 6 by 3, because then I'd have 3 times 6, that would be 18y. And then I can multiply 9 by 2, and then I'd have 18y there, but I need them to be opposite, so pick one to be negative. Okay? Alright, 2 more examples here. So if we look at example 5 here, they're lined up, but we don't have opposites. So we can get rid of the x's, but what draws me to them is the y's, because they're the same number, 1, but one of them needs to be negative 1. So I'm going to take the bottom equation, I could do the top, and I'm going to multiply everything by negative 1. So now it becomes, the first one doesn't need anything to happen to it, but here we're going to have negative 1 times 3 is negative 3x, Negative 1 times positive 1 is negative 1y. And negative 1 times 1 is negative 1. Okay, so these are going to cancel out. 5x minus 3x is 2x. 2 minus 1 is 1. Divide by 2. And we get that x equals 1 half. Okay, then to get the y value, we need to take 1 half and plug it back in to one of the original equations. It doesn't matter which one. So if I'm going to use, so to do the last step, step 5, I'm going to pick one of these. I'm going to go with the bottom equation just because the numbers are smaller, but it doesn't matter. And I'm going to take the x, and I'm going to replace x with 1 half. So 3 times 1 half is 3 and a half. I'm going to subtract 3 halves. And we get y equals, find a common denominator, we get negative 1 half for y. So my solution is 1 half and negative 1 half for y. Okay, last example here. They're all lined up. I gotta make opposites. So what's drawing me to it is either I can multiply the denominator by negative 2 to get rid of this, or to make this negative 12x, or I can multiply by negative 2 and then the y's would go away. So I'm going to take the bottom equation. So step 1 we skip. They're already lined up. So step 2 is I need to make them opposites. So I'm going to distribute. Negative 2 times 6x is negative 12x. Negative 2 times negative 2 is 4y. Negative 2 times 8 is negative 16. Okay, step 3. We're going to add. Those cancel. Those cancel. So there's nothing here. But on this side we have negative 12. 0 equals negative 12. That's not true. That is false. So that gives us an answer of no solution. If instead we had a solution of 5 equals 5 or 6 equals 6, instead of this, if we had gotten this, that tells us the answer is infinitely many solutions. So if this was true, this would be the answer. But this one was false, so no solution.